Hello, my name is Jodhani Vanshi Devji. My roll number is 41. My topic is perfect number. Index. What is number? Perfect number. History. Even perfect number. Odd perfect number. Unproven math fact in relation to perfect number. Which professions might make use of perfect numbers? Tips and tricks. Important notes. How many perfect number are there? The quite interesting unsolved problem uses. What is number? A number is a mathematical object used to count, measure and label. Here is the chart of the number system. डेसिमल नंबर सिस्टम. हम डेसिमल नंबर सिस्टम को टू वे में डिवाइड कर सकते हैं. रियल नंबर माइनस इन्फिनिटी टू प्लस इन्फिनिटी एंड इमेजनरी नंबर √-2, √-3 एक्सेट्रा. हम इमेजनरी नंबर को एक ही वे में डिवाइड कर सकते हैं, वो है कॉम्प्लेक्स नंबर विच इज़ 2 + √-2, 3 + √-2 एक्सेट्रा. रियल नंबर को हम टू वे में डिवाइड कर सकते हैं, रेशनल नंबर एंड इरेशनल नंबर. इरेशनल नंबर इज पाई, एक्सपोनेंशियल नंबर √2, √3 एक्सेट्रा. हम रेशनल नंबर और इस इरेशनल नंबर दोनों को टू वे में डिवाइड कर सकते हैं. रेशनल नंबर को फ्रैक्शंस विच इज़ 1/3, 2/3, 3/5 एक्सेट्रा एंड इंटीजर्स नॉन डेसिमल नंबर्स. एंड इरेशनल नंबर को भी टू वे में डिवाइड कर सकते हैं, ट्रांसेंडेंटल नंबर एंड सर्ट्स. ट्रांसेंडेंटल नंबर इज पाई, एक्सपोनेंशियल नंबर एक्सेट्रा एंड सर्ट्स आर √2, √3 एक्सेट्रा. Negative integers and whole number. Negative integers is -∞ to -1 and whole number is 0 to positive integer. होल नंबर को हम 6 वे में डिवाइड कर सकते हैं. नेचुरल नंबर विच इज़ 1 to पॉजिटिव इंटीजर, प्राइम नंबर विच इज़ 2, 3, 5, 7 एक्सेट्रा. कंपोजिट नंबर 4, 6, 8, 9 एक्सेट्रा. इवन नंबर 2, 4, 6, 8 एक्सेट्रा. odd number 1, 3, 5, 7 एक्सेट्रा एंड परफेक्ट नंबर 6, 28 एक्सेट्रा. सो हु इज़ परफेक्ट नंबर. अब हम आके देखेंगे परफेक्ट नंबर क्या क्या है. परफेक्ट नंबर. इन नंबर थियरी अ परफेक्ट नंबर इज पॉजिटिव इंटीजर दैट इज इक्वल टू द सम ऑफ इट्स पॉजिटिव डिवीजन एक्सक्लूडिंग द नंबर इटसेल्फ. जो नंबर है उसके जो डिवीज़र है उसका जो सम है वो जो हमने जो नंबर लिया है वो ही आना चाहिए. वो नंबर जो वो खुद नंबर है वो हमें नहीं लेना है. एग्जाम्पल देखते हैं. फॉर एग्जाम्पल 6 हैज़ डिवीज़र 1, 2 एंड 3. सो 1 + 2 + 3 = 6. यहाँ पे हमने 6 खुद को काउंट नहीं किया है, उसके डिवीज़र को काउंट किया है. सो 1 + 2 + 3 = 6. नाउ वी टेक एनी नंबर 9. सो इट्स डिवीज़र इज 1 + 3 + 3 which is equal to 7. So 9 does not equal to 7. So 9 is not perfect number. Perfect number table. Prime p, Mersenne prime 2p - 1. Perfect number 2p - 1 into 2p - 1. We take prime p equal to 2. So Mersenne prime is 3 and perfect number is 6. Now we take prime p equal to 3. So Mersenne prime is 7 and perfect number is 28. History. Euclid, Nicomaus and Philo of Alexandria. In about 300 before Christ, Euclid saw that if 2p - 1 is prime, then 2p - 1 into 2p - 1 is perfect. The first four perfect numbers were the only ones known to early Greek mathematics, and the mathematician Nicomaus noted 8128 as early as around Anno Domini 100. In modern language, Nicomaus states without proof that every perfect number is of the form 2 raised to n minus 1 into 2 raised to n minus 1, where 2 raised to n minus 1 is prime. He seems to be unaware that n itself has to be prime. Philo is followed by Origen and by Didymus the blind, who adds the observation that there are only 4 perfect numbers that are less than 10,000. अब हम परफेक्ट नंबर को टू में डिवाइड करेंगे, इवन परफेक्ट नंबर एंड ऑड परफेक्ट नंबर. सो इवन परफेक्ट नंबर, यूक्लिड प्रूव दैट 2 raised to p minus 1 into 2 raised to p minus 1 is an even perfect number whenever 2 raised to p minus 1 is prime. For example, the first 4 perfect numbers are generated by formula 2 raised to p minus 1 into 2 raised to p minus 1, with p is the prime number as follows. For p equal to 2, even perfect number is 6. For p equal to 3, perfect number is 28. For p equal to 5, perfect number is 496. And for p equal to 7, perfect number is 8128. The first 47 even perfect numbers are 2 raised to p minus 1 into 2 raised to p minus 1. For p equal to 2, 3, 5, 7 up to 4, 3, 1, 1, 2, 6, 0, 9. For higher perfect numbers have also been discovered, namely those for which p equal to these given 4 numbers, though there may be others within this range. Odd perfect number. It is unknown whether there is any odd perfect number, though various results have been obtained. Euler state whether there is any odd perfect number is an almost difficult question. More recently, Karl Pomerance has presented a heuristic argument suggesting that indeed no odd perfect number should exist. All perfect numbers are also always harmonic number, and it has been constructed as well that there are no odd or harmonic number other than 1. Any odd perfect number n must satisfy the following condition. अगर कोई परफेक्ट नंबर इस सभी कंडीशन को सेटिस्फाई करता है तो वो ऑड परफेक्ट नंबर होगा. अभी तक कोई ऑड परफेक्ट नंबर मिला नहीं है. सो n ग्रेटर देन 10 raised to 1500, n is not divisible by 105, n is the form of n congruence 1 modulo 12 or n congruence 117 modulo 468 or n congruence 81 modulo 324. n is the form of n equal to q raised to alpha p1 raised to 2e1 up to pk raised to 2ek, where p1, q1, q, p1, pk are distinct prime. q congruence alpha congruence 1 modulo 4. The smallest prime factor of n is less than 2k plus 8 divided by 3. Either q raised to alpha greater than 10 raised to 62 or pj raised to 2ej greater than 10 raised to 62 for some j. n less than 2 raised to 4k plus 1 minus 2 raised to k plus 1. Alpha plus 2e1 plus 2e2 plus 2e3 plus and up to 2ek greater equal 21k minus 18 divided by 8. q, p1, p2, p3 up to pk greater than 2n raised to 17 by 26. These all are the condition for n must satisfying, then n is perfect number, odd perfect number. Unproven math fact in relation to perfect number. All known perfect numbers end in 6 or 28. But again, that may not be true for perfect numbers after the 51 that have been found. It is said that perfect numbers are infinite, but since only 51 have been found, this cannot be proven. Which professions might make use of perfect numbers? What's more, with the world very quickly turning towards technical solution and automation, we are constantly interacting with machines and devices, so our knowledge of perfect number and other math theories are a huge bonus for jobs whereby we need to input mathematical data to teach a computer specific sequence or, or the like. So it's example of professions where perfect number is used: chartered account, financial manager, research scientist in maths, operational researcher, and software tester. Tips and tricks: the kth perfect number has k digit. All perfect number are even. It is still unknown whether all perfect number exist or not. All perfect numbers end in 6 and 28 alternatively. The sum of all divisor of perfect numbers gives the result as twice perfect number. Important note: first, perfect number are the positive integer which are the sum of its proper divisor. Second, the smallest positive integer is 6. Third, 2 raised to k minus 1 into 2 raised to k minus 1 is a perfect number. Fourth, the only स्क्वेयर फ्री परफेक्ट नंबर इज 6 बिकॉज यहाँ पे सिक्स का डिवीज़र क्या है, 6 इक्वल टू 1 2 एंड 3. यहाँ पे किसी का भी स्क्वेयर रूट में हमें नहीं मिलेगा. अगर हम 28 देखते हैं तो 1 4 7, so 4 is square of 2. So 28 is, so here 6, only one number 6 is a square free perfect number. Fifth, a perfect number is called or a harmonic number if the harmonic means of its divisor an integer. How many perfect numbers are there? It is still unknown whether there are infinite perfect number or not, but till now we have 51 perfect numbers. The quite interesting Philo of Alexandria in his 1st century book on the creation mentions perfect number claiming that the world was created in 6 days and the moon orbits in 28 days because 6 and 28 are perfect. The first picture of world was created in 6 days. And second picture is moon orbit in 28 days. Unsolved problem: how many even perfect numbers are there? More precisely, are there infinitely many or finitely many? In the latter case, just how many are there? Are there any odd perfect numbers? Use is: we need the natural number to count, we need the real number to measure, and we need the complex numbers to guarantee that every quadratic equation has solutions. If some mathematician can create a nifty bit of theoretical mathematics, eventually some other mathematician will find a nifty use for those ideas. Thank you.